I kept on calling that a container is actually a micro compute instance. But I never proved it, right? Because we are doing proof of concepts. So we are calling it as a compute instance, micro compute instance, but I never gave you an evidence to saying that yes, it has the characteristics of the compute nodes. And what is the characteristics of the compute? It should have its own CPU, memory, storage, and a network interface. So these are the four minimum things that needs to have in a compute node to function it, to make it functional. So now let's get into a container and try to see whether all these components are there in the container or not. For that purpose, what I'll do is I will turn on my prod node, because we are using prod node to run the containers. By the time it is being turned on, let me pause the video. It is running now. I will log in using our username, which is demo that we had created, to find its IP address, which is 105. I will access this particular system from outside the console so that we can make the screen large. I have already created this profile and you can see. So we are going to access it. By the time it is connecting, I'll change the setting to make the font size large. Use this setting. Yes. Here we are. So now, first of all, let's go and create a container. But before that, let's try to see does this system had any image or not. Docker image ls, yes, it has 2 images. Let's also validate whether it has any container running here. No, we have no container. Let's also validate. No, we don't have any container in running or stopped or in error state. That means now in order to validate, in order to prove that a container has its own dedicated storage, CPU, memory, and IOPS also, storage IOPS that you can see, plus the network interface. So to do so, let's first create a container, and the command to create a container is, you remember because we have done many times, docker run hyphen whatever name that we want to give. Let's say we want to give ubuntu test, and then followed by -d to run on the background, -p to publish the port, followed by the expose port, and then the name of the image that we want to use, followed by the repository name. And here is the tag. And then enter. My container got created. Let's go and validate. Yes, container is running and functional. Now it is time to validate the system specification of the container to make sure the 4 major components of the functional compute is there in the particular container. Let's start with the CPU, RAM, and IOPS first. So docker stats command is used to find the system specification of the containers that are running. So you can see this is my container ID, and then this is my container name. This is the CPU percentage that is being used, and this is the memory usage, and this is the limit of the memory that is allocated. So here you can see, so this much is the memory which is allocated to this, just because we are not using this. And the good part of the CPU and all, it is shared here. So that means whatever requires, so you can either hard code it, define it. Just because we have not defined in our Docker file, it is using based on the requirements, based on the demands that we have. Similarly, you can see on the memory side also. So dev node, you remember we had given almost 2 GB of RAM, and this much of the available from that, and it is available to the container also, just because we have not specified the particular system specification. So you can see it has its own CPU, its own memory, and its own network interface IOPS, and then block storage IOPS also. So just because it is not in function or not in actual service, we see it is all 0, but once it will start functional, it will start consuming it. So these are the things that you can see. It has its own CPU, memory, network interface, network IOPS, and storage IOPS. So these are the few things that you can see. Now let's try to see the network information. To see network information, we need to use docker container inspect command, followed by the docker, the container name that we want to inspect. Okay, the container name was ubuntu test. So you can see, so here we are. It has its own network interface along with the gateway, IP address, subnet mask, everything, right? So that means you can easily see this particular container has its own interface, network interface, IP address. This means network plus CPU, RAM, its own network IOPS and storage IOPS. Now let's try to find the storage that it is given to this particular container. The command to find is, there are two commands. We can either use docker ps hyphen size followed by the name of the container, or directly when there is not much container. Okay, so you can say the actual size of the container, the image was 248 MB, but that is stored locally in the system. But in runtime, it is only using, because whatever image is stored, right, it is working as the base storage, and then the in order to function the container, it needs additional 2 bytes, because there is nothing at present is running in this particular container. Okay, so this is how you can see it has its own storage capacity also allocated to this. Just because we have not defined, it is taking whatever basic minimum needed at present, and depending on the requirement it will keep on increasing, and it will keep on pulling from the actual capacity that is allocated to the node. If we define it in the Docker file, it is going to have at least those minimum capacity there. Now let's see one more command that can be used. So which is docker system df. So this is another command that you can see. So it is saying we have total of 2 images on this Docker node. File size is this, and this is the basically the average size of this. And then you can see I have one container which is active, and only 2 byte is needed to run the containers at present, because actual image is stored locally on the drive, and this is the storage that is attached to that particular container, because there is nothing much running in that particular container. So only 2 byte of memory given, 2 byte of storage is given to container at present. So this is how you can see. So a container has its own dedicated or allocated at present CPU, RAM, network interface, IOPS, block IOPS, network IOPS, and then storage also. Now, just because it is a container, it is a microcompute instance. That means whenever we required, we can update the container, the specification also, right? So let's try to update at least one component. So let's try to update. So at present, it is having 1.795 GB of RAM. Let's reduce it, and so that we can see. And the advantage of this container is we can make the changes, even system changes in runtime without impacting the service. So let's do this. What we are going to do is, for this we will use command which is docker, and update function we need to use, because we are going to update it. So update, we are going to update what? You can take help if you are not able to find it. So you will find, we are good. Let's try to update the memory. And in order to update memory, we need to update the swap memory also. So memory of the swap memory and memory must be configured properly in order to run in order to run properly. What we are going to do is we'll update both the things. So my command is update followed by the memory. So we are going to give, let's say, 256 MB MIB. And then we need to update the swap memory also, otherwise it is going to give error. Or let me show you what is the error that we are going to get first, and then I'll fix it. Memory, and then which system we are going to update? It is Ubuntu test. So we are going to update the memory from whatever memory is configured to 256 MB of this Ubuntu system which is running at Ubuntu test. I'm going to get error, of course, because the default practice is memory limit should be smaller than the already set memory swap limit. Okay, so whatever memory swap we have defined, it must be smaller, whatever we are changing. That's why whenever you are changing for container, try to define both the memories together. So what I will do is I'll define swap memory also with the same size, which is 256 MB, and then the container name, which is Ubuntu -test. That's all. Yeah, so without any error, command got executed. Let's go and see the size stats again. Here we are. So earlier, the default size, default limit that was given to this particular system was the 1.6, 1.975 something GB. But this time you can see, just because I have defined it, hard coded it, it is given it to by default, and out of this it is being used this much. Okay, that means we have, like normal compute, we need to define, we can define the system specification. If it is physical, you need to add the memory, add the resources physically. If it is virtual, you can power off the VM and then you can increase the specification. And similarly in container also, you need to define the system specification. If you have not defined, it is going to like randomly or use it based on the requirement. And if you have defined it, it will be defined, of course. And the good part of it, you can define the storage and memory and capacity even in runtime without impacting the service. This is the advantage of having container. One more advantage out of whatever we had discussed in past. With this, hope you are able to understand why there is no harm calling a container as microcompute instance, because it is very small in size, but it still has all the specifications like normal computes. So we can call it microcompute instance, and we can optimize it, we can upgrade it, modify it based on the requirement. That's all for the day. Hope you enjoyed watching. If you find it useful, please encourage us with your comments, likes, shares, and subscriptions. Thanks for joining. Stay tuned for more videos.